Greetings, YouTube. Beautiful mind here. I had this question that came in. It's just an image. It's just this image. There's another question that says find the area. So I'm assuming that this is also find the area, and I think it's round to the nearest tenth if necessary. So you want to just break it up into its basic shapes, right? Okay. So let's do like this. Let's go here. I'm going to shrink this down because I need some space. As soon as I can. There we go. So let's look at it based on its basic shapes, right? So it looks like we have, like, let's do like this. We have something kind of like this going on. 1, 2, 3, 4. Let's see, 8, 2, 4, 6, 2, 4, 6, 8, 2, 4, 6, 8. Okay. Okay. That's good enough, right? That's the gist of it. Okay. So if we look here, look at our basic shapes, notice that we have something like this going on here, and then this, and notice that we have a 90-degree angle right there. It says that from here to here is 15 centimeters. So that stretch is 15 centimeters. And then it says from here to here is 8 centimeters. All right? That's what we're given. Okay? So you want to break it into the basic shape. What basic shapes do you notice? All right? Can you notice any basic shapes, right? So let's see here. Like, for instance, if we look here, boom. We have that basic shape. The color's fine, I guess. Okay. So it looks like it looks like an isosceles triangle. I'm kind of eyeballing. I am kind of making an assumption. But yeah, it looks like an isosceles triangle. Okay. So let's draw that. Let's just copy that, I guess. Yeah, copy. So that's one basic shape, and the other is half of a circle, right? We had drew that circle earlier. Okay. I guess I can just copy that as well. Paste. Okay. So we have this half of a circle. So let's see. So it says that from here to here is 8 centimeters. So from there to there is 8. If it's drawn to scale, this should also be 8 centimeters. So from there to there, so that gives you that whole side. All right. Let's see, what else do we have? We know that this is a 90-degree angle. We know that the altitude is 15 centimeters. Okay. So I'm going to take this triangle. I'm going to rotate it, just to stand it up. Boom. Anyway, and so the height is what, 15 centimeters, or the altitude is 15 centimeters from here to here. Okay. So then the area for a triangle. So then area of a triangle is 1/2 the base times the height. All right. So then in this orientation, we're going to say 1/2. The base is what, 16 centimeters, and the height is 15 centimeters. So then 8 times 15 is 80 plus 40 is 120. So 120 centimeters squared. Area. The units for area is always squared. Okay. That's about the. Oh, that's just of the triangular portion. Then for area of a complete circle is going to be pi r squared. But since we have half the circle, we're going to do half of that. So our formula is going to be half pi r squared. All right, because we have half the circle. Okay. So then that's going to be 1/2 times 3.14. And the radius of the circle is what? 8 centimeters, right? So 4 pi is the exact amount, right? So then we just add the areas of the two basic shapes together. So the exact answer would be, area would be 120 plus 4 pi centimeters squared. But then I think the instructions say round to the nearest tenth. So we're going to go ahead and crunch that number. I'm going to break open my calculator. Cool beans. All right. Let's just reload and refresh so we know it's working properly. Okay. So then I'm just going to do 120. Now pi, you can get away with, 3.14 for pi, plus 4 times 3.14. Okay. Actually, I'm going to hit the pi button, though, since I have it. So it's right here. Second, the caret symbol. I'm going to get rid of all the other stuff. Okay. So the nearest tenth is going to be 0.6. So we're going to say that this is approximately 132.6 centimeters squared. Okay. That was the other one. Okay. So that's about the best we can do. So basically we broke it into the basic shapes, found the area of each basic shape, and then added those areas together. Okay. And then with this one, it says that Scott is constructing a deck like the one shown. What's the area of the deck? Let me see here. We could do basic shapes. Let's see. Okay, so it looks like an octagon. Okay, I think those tick marks, like this tick mark and here, all of those, that means that they're the same size. Usually that's what that means. Let's see. Now it says that drop down from the top to that corner is 3.5. Let me get a copy of this image. I'm going to use this color just to match. Almost. It'll do for now. Let's just move it. It's just those two that are off. Let's see if we can straighten those guys out. Okay, I got a plan. What I'm going to do is the following. So about 3, right? So let's go 1, 2, 3. I'm just being a little meticulous. So I know those are the same size. Okay, that'll do. I see what I'm going for. I'm just being a little whatever. OCD, just a little bit. Let me see. 1, 2, 3. It's not going to be exactly the same, but that's fine. The idea is there. 1, 2, 3. me just a moment. If that's 3 and that's 3. Should be dialed back a little bit. I'm gonna go like this. 1, 2, 3. 1, 2, 3. Let me see. This is fine. This won't get the job done. I was trying to see if there's a quick way for me to make it like exact, but I'm not seeing it. But anyway, okay, so this is here. Now it says the diameter across the middle. So this is 12 feet. Call it back. Good. Hey, let me call you right back. I'm making a video.
I can't hear you.
Let me call you right back. I'm making a video.
Okay.
All right, see. So this is 12 feet. So across the middle, right? So basically from there, so from here to here, okay? Now it says that this top part, so from here to here is 5 feet. So from here to here, okay? And then it says the drop down is 3.5. So this is 3.5 from here to here. Okay. What else do we have? And all of those are supposed to be the same size. That's fine. So we want the area, right? Okay. So the basic shape that I think it's a square. Right? It looks like a square. So let me draw the square that I see. It's right here. I mean, I'm gonna let me undo. And we can confirm that it actually works, I guess, but ooh, totally missed. Yeah, that's better. Okay. So that's what I see. So we might be able to find those triangles, like basically find the area of the square. I'm trying to I guess I'm hesitating to see if this will work. Let me see. If across the middle is 12 and that's 5, then there's what, 7 left over? So that has to be 3.5. So each of those are 3.5. Okay. So if that's 3.5, that's 3.5, and that's 5. Does that make a square? So will that work? Okay, let's see. So I guess the image that I'm kind of stuck on is this one right here. Let me see. 1, 2, 3. 1, 2, 3. And this is that one, right? I just wanted to make sure that it actually makes a square. Because if it does, then I think we're golden. So let's see. If this is 3.5 here, this is 3.5, and this is 5, can we have a triangle with these dimensions? With this being a 90-degree angle. Okay. So what we would do is see, does it satisfy the Pythagorean Theorem? A squared plus b squared equals c squared. Okay. Whenever we have a right triangle, this should hold. So then what should be the case? It should be the case that 3.5 squared plus 3.5 squared. The question is, does that equal 5 squared? Ooh, I don't think so. And if not, then that's not really a triangle, which it shouldn't be. So I think that was an assumption that I was making. Let me just crunch that number real quick. It shouldn't work, but let me just confirm. Okay, so if we said 3.5 squared plus 3.5 squared. Oh, it's so very close. That sucks. That's why I was hesitating. I was like, it's close, but it should not work out, and it doesn't. So it's not a square, so I'm going to scrap that idea. But we still have other ways that we can look at it. So I'm going to scrap all of this. I'm going to get rid of this guy too. Okay. So now we do have that drop down is 3.5, and we still can break it into basic shapes. Let me see. Let me think about it. Give me a moment. So another way that we could look at it, you have like a trapezoid. You have several different ways that you can look at it. I'm trying to keep it as simple as possible. I don't automatically know the formula for area of a trapezoid. I could look it up really quickly, but if I'm going to do it off the dome, right? Now we can look at this triangle here, right? So that one occurs, what, 1, 2, 3, 4. There are 4 of those, okay? So let me highlight that one. We have, let me change the color, style, fill. Okay, so we have 4 of those triangles around this image, and then I think this is a square, 5, 5. Nope, that's not a square either, huh? Okay, so if we look at this image here, what do we know about this one? Style and the fill. All right, that blue part. That's not. It shouldn't actually be a square. Okay, let's analyze that blue one, that blue basic shape. But once we get those 2 basic shapes, I think we're good to go. Let's paste. Now this one, right? We know that the top is 5, so that means that this side is also 5. Okay. And then it looks like the sides, this should be 3.5 and this is 3.5. Now that shape occurs 4 times, but then the center should be a square. The center should be a 5 by 5, right? It should be 5 all around. Hopefully that's not too confusing. Yeah. So I see 3 basic shapes. You have basically 4 of these guys, 1 of this guy, and 4, so darker color. We have 4 of these triangles, right? So we could find the area of those basic shapes and add them up. Because at first I was going to try to do the square thing, but it didn't actually work. So I think this will work. I'm going to go with this, okay? So now for the green triangle, again, we can use area of a triangle is 1/2 the base times the height. Let me see. The base, what is that distance from there to there? I think they're both 3.5. So it looks like it's going to be 1/2 3.5 times base times the height times 3.5, right? Okay. And then we said that one occurs 1, 2, 3, 4. That one occurs 4 times, so we're just going to multiply by 4. Okay, and we'll crunch that number in just a moment. This lone square, so the area of this lone square is going to be, what, 25? What are the units? Feet? Feet squared. Okay. And then this other square, my dog is snoring over there. I just made it a little bit different color. Length times the width. So area of a square is, well, it's not really a square, it's a rectangle, but length times the width is going to be 5 times 3.5. Okay. 15 plus 2.5 is 17.5 feet squared. Is that right? Yeah, slightly over 15, right? 2, let me see. If that was 4 times 4, it's going to be less than 16. I don't know 35 times 35. Let's go here. Come on. All right. Let's do 2 times 3.5 squared. 24.5. Yeah, that's for all four, right? That one occurred once. This one, I think we still need to multiply that one by 4. So this green one, 24.5 feet squared. The blue one, 25 feet squared. Okay. And then this other one, again, that one occurred 4. So we do need to multiply by 4. It's one of these. Is that the one? So we need to say, let's just get rid of this. So we need to say this times 4, right? Because that one occurs 4 times. So 20 times 3.5, let's see, 770? Let's see if these numbers make sense. 35. I feel like something might be off. Okay. So then if we add all these numbers up, it looks like we get a 70 plus 25 plus 24.5 to total 75, 85, 95, 99.5 feet squared. I think that's it. So I just tried to get it to the basic shapes and tried to use geometry a little bit. And just tried to confirm the numbers as best I could. Okay. I can't think of anything else there. Hopefully that wasn't too all over the place. Right? And that's not the only way to go about it, but that's just what I could immediately see. And trying to honor the scales. Because you know that the drop down is 3.5. So then I factored that in over there. Like here. This has to be 3.5, right? And this is 5. So then you have this one. This one occurs 1, 2, 3, 4. But then this one should definitely be a square, right? 5, 5, 5, 5. And then we have 4 of these triangles. Okay. Another way you could have looked at it as like a trapezoid. I think the area for a trapezoid is 1/2 base times height. 1/2 base 1 plus base 2 times the height. So just as an alternative, if we look at this trapezoid here, all right, 1/2 base 1, 1/2 base 1 plus base 2. So this plus this times the height. Let me see if that works. Because we have 2 of those and then a rectangle. Let me try that one. So I'll do that entire one in purple just to see if I get the same number. Okay? I'm going to say alternative. Now, if my formula is correct, that's not a really good trapezoid. I think it goes 1/2 base 1 plus base 2 times the height. All right, so that's going to be, and we have 2 of those, so I'm going to say that this is times 2. So basically, these are going to cancel each other out. So then the base is from the top to the bottom, so that's 12 plus, that one is 5. And the height is here to here, which should be the same as this. Should be 3.5. Okay, so we captured both of them. We'll get a number there, and then we need to find the area of that middle rectangle. So the area of the rectangle is going to be the length times the width. So that's going to be 5 times this drop down is what, 12. Okay, let's get those 2 numbers and see how they add up. So I'm going to go like this. So then, what is that, 17? 17 times 3.5 plus 60. Oh, now we got 119. Let me look at it. 1/2 base 1 plus base 2 times the height. I think that's the right formula. But then that occurred twice. So then we remove the 1/2. I think that's 12, right? See, now it's irking me. I'm trying to think. I'm gonna go ahead and look up the. I just want to make sure I have the right formula for areas of trapezoid before I submit this. So obviously I'm doing this all on the fly. Let me pull up my book real quick. I think it's in my college algebra book. Let me see. I think it's in this one. Oh, I hadn't even downloaded it. Okay, where else? I think I have it over here while that's loading. Is that the right one? I'm going to let that just do what it's doing. It'll probably be done, but it's going pretty quick. So I'm going to just let it finish. What edition is that? I think that's the right one. I guess I could have just Googled it. Here, let's do this. Hey Siri, what's the formula for area of a trapezoid?
Just a moment. Here's what I found from ThoughtCode.
1/2 base 1. Yeah, that's right. 1/2.
Expressed in the formula 8
Yeah. We got it. Okay, so I'm going to stand by that. Okay, but now I've got different numbers. So now one of these, more than likely, one is correct and one is not. 5 times the 12, right? Is 50 plus 10 is 60. That one occurred twice. 1/2 base 1 plus base 2 times the height. So that occurred twice. 17 times 3.5 plus 60 is 119. 25. That one occurred what? 1, 2, 3, 4. 20 times 3.5. Let me crunch this number over here. 20 times 3.5 is going to be that. I think we got that 70. 2 times 3.5 squared. Okay, and we got that one. And 5 times 5 is 25. Oh. Let me see. 70 plus 24.5 plus 25. Oh, I just added wrong. Gadur. That's what it was. I was like, why is this not working out? Man. That's what happens when you get surprise math attack. I was totally like gaming when I got this question, so I had to like put it off until I finished gaming. The game takes like 30 minutes a match, so I'm like coming off a high. All right, so I got the same number. I was like, why are they not working out? They should be working out, and they did work out. I just didn't add correct at the end. Okay, so 119.5 feet squared. I'm glad I didn't submit that first when I looked at it again. Okay, that was fun. But that's how it goes. Like you have to kind of get an answer, then you ask yourself, does it make sense? So I did it 2 different ways, and I got the same answer in either time. Even over here, when I did it this way, I still got the 119.5 feet squared. Okay. So I did it 2 different ways. The purple is where I did 2 trapezoids with a rectangle in the middle, and the blue and the green is where I did basically 5 different rectangles and 4 different triangles. To add them all up. But in either case, we got the same answer. Okay, that makes me feel much better. Okay. So, that was a lot of fun. All right, so on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your evening. Peace.